and the most important chapter. In this chapter, we will learn time management process, schedule baseline, schedule compression techniques like crashing and fast tracking, activity list, network diagram, dependencies, critical path, float, milestones, resource breakdown structure, estimating techniques, reserve, and many more. Let's move on. Time management is what most people think of when they think of project managers. It's where the deadlines are set and met. It starts with figuring out the work you need to do, how you do it, what resources you will use, and how long it will take. From these plans, you have to develop and control that schedule. In a word, time management is planning and exercising conscious control over the amount of time spent on specific activities. As you can see, most of the processes involved in time management are planning. We will be covering each and every process in this chapter. There is an old joke when it comes to project management time. The first 90% of a project schedule takes 90% of the time. The last 10% takes the other 90% of the time. And isn't that the way it goes? Hopefully not, but far too often, yes. The importance of planning a project is never as evident until the rush to completion. Project time management is a subset of project management that includes the processes required to ensure timely completion of the project. It consists of planning schedule management, activity definition, activity sequencing, activity duration estimating, schedule development, and schedule control. Without proper time management, a project can head towards a disaster. So, time planning is mightily important. Effective project management requires adequate time for planning. The importance of planning a project is never as evident until the rush to completion. The final actions to complete a project are dependent on the plans and motivations set in the project planning processes. Planning for project schedules may stem from deadlines, customer demands, hard and soft logic, and a bit of prediction. We will learn more on time management. Time management is an essential element on the PMP exam. You'll need a solid understanding of the activities and methods to predict and account for proper time. Time management is crucial to not only passing the PMP exam, but also to successful project management. Let us discuss schedule management planning. Even though most of us call the output of these processes a schedule, scheduling gurus refer to it as a schedule model, and they're right. The schedule is just a model of what could happen if all the assumptions in the schedule data, such as activities, sequences, durations, and resources, are correct. From the purist perspective, the project information is entered into a tool, like scheduling software. That is combined with a scheduling methodology, such as critical path or critical chain, to develop the schedule model. The output can be in the form of a bar chart or network diagram, with dates or any other presentation that meets the need. Some terms can be confusing. Don't worry, we will cover all the terms. Plan schedule management defines policies, procedures, and documentation for managing and controlling project schedule. It provides guidance and direction on how the project schedule will be managed throughout the project. Let's continue. As far as inputs are concerned, the most important ones are the scope baseline, because that represents the work that needs to be done, and the schedule will tell you how much time is required to do it. Scope baseline means project scope statement, WBS, and WBS dictionary. The project charter will give the high-level time constraints and the list of critical milestones to be achieved on the project, some of which may actually be tied to project approval requirements, like the project may absolutely have to be done within a certain amount of time. Expert judgment and meetings should be familiar by now as typical techniques that project managers of creating something as complicated and intricate as a schedule. Let's discuss analytical techniques. The project management plan process may involve choosing strategic options to estimate and schedule the project, such as scheduling methodology, scheduling tools and techniques, estimating approaches, and software. Finally, the output, as you could probably guess by the title of the process, is the schedule management plan. Define activities is the process of identifying and documenting the specific actions to be performed to produce the project deliverables. The process uses decomposition technique to take the work packages identified in the WBS, which are nouns, and to identify the activities, which are verbs, required in order to complete them. It is a good concept to understand why you need to define activities. It is, therefore, the bridge between the planning involved in scope management and the planning involved in time or schedule management. In Define Activity process, each work package will be broken down or decomposed into individual work schedule activities, and it is the activity list that means define activities created within this process that is used to develop the remaining time management processes. Let's check their input, tools, and outputs. To define activities, you start with your scope baseline, in particular, the work breakdown structure WBS. The WBS contains the work packages that you will decompose to determine activities. The scope statement, which gives a detailed narrative description of the project, contains assumptions and constraints that need to be considered. You can use organizational process assets, such as information from previous projects or templates to help you. The organization's information system, including the preferred software for schedule development in an enterprise environmental factor that guides your approach to recording the activities. When you create your WBS, you decompose the work to create work packages. Using rolling wave planning is common when identifying all the activities and developing the schedule. With this approach, you can see how the process of planning and developing the schedule occurs throughout a project. Usually, your team members identify the activities needed to complete the work packages. They have the subject matter expertise necessary to identify all the steps and all the work needed. In some organizations, you will be able to use a schedule from a similar project to get a head start, but you will still need to have your team members review it and modify it to meet the needs for your particular project. The process outputs are activity list, activity attributes, and milestone list. Activity list includes all scheduled activities on the project. Activity attributes extends the description of each activity by having multiple components associated with each activity. Milestone list are the lists of all mandatory and optional milestones. We will be discussing this. Decomposition is an important concept. Let's discuss more on this topic. The WBS, the collection of deliverable-oriented components, must now be broken into activities. Specifically, the work packages within the WBS must be decomposed into manageable work elements. Can you guess? What's the difference between decomposing the project deliverables and the project work? The elements in the WBS are deliverables. This process is concerned with the actions needed to create the deliverables. It's quite possible to create the WBS and the activity list in tandem. Don't get too caught up in the timing of the activity list definition and the WBS. Simply put, the WBS describes the components of the deliverables. The activity list defines the actions to create the deliverables. We already know that the primary output of decomposing the work is the activity list. The activity list is a collection of all the work elements required to complete the project. The activity list is actually an extension of the WBS and will serve as a fundamental tool in creating the project schedule. The activity list is needed to ensure that all of the deliverables of the WBS are accounted for and that the necessary work is mapped to each of the deliverables. The activity list also ensures that there is no extra work included in the project. In addition, the work on the activity list includes descriptions of each identified activity. Actually, this accomplishes three things. A. It ensures the team members are in agreement on what the work package accomplishes. B. It ensures the work supports and creates the WBS deliverables. And C. It ensures the work is within the project scope. Activity attributes is needed to hold additional information about each activity and will typically include the individual to carry out the work or the knowledge, skills, and experience required. It may also include non-human aspects, such as materials, tools, or facilities. For these reasons, the activity attributes should be seen as an expansion of the activity list. Attributes can be codes, predecessor and successor activities, logical and other relationships, leads and lags, resource requirements, target dates, constraints, and assumptions. Now that the activity list has been created, the activities must be arranged in a logical sequence. This process calls on the project manager and the project team to identify the logical relationships between activities and the preferred relationship between activities. There are many approaches to completing the activity sequencing. Perhaps the greatest approach, however, is that activity sequencing is done with the project team, not as a solo activity. This logical sequencing is a work which will accomplish the work of the project with the greatest amount of efficiency given the other project constraints. Remember, first activity in a plan has no activities preceding it, and the last activity within a plan has no activities succeeding it. After completion of the activity, we can obtain network diagrams. Here are some basic concepts for applying lead and lag. Use leads and lags to support realistic and achievable project schedules. Each activity is connected at least to one predecessor and one successor, except the start and the end. Lead may be added to start an activity before the predecessor activity is complete. Lag is the inserted waiting time between activities. A lag is an imposed delay in starting a successor activity. It can be internally imposed or externally imposed, depending on the situation. Use leads and lags to support realistic and achievable project schedules. Network diagrams visualize the project work. It shows the relationship of the work activities and how the work will progress from start to completion. It can be extremely complex or easy to create and configure. Most network diagrams in today's project management environment use an approach called activity on node to illustrate the activities and the relationship between activities. Older network diagramming methods used activity on arrows to represent the activities and their relationships. The precedence diagramming method, PDM, is the most common method of arranging the project work visually. We will discuss this on the next slide. PDM is also known as AON, which means activity on node. It's the most common approach to network diagramming, since it's used by most project management information systems, but can also be done manually. The PDM puts the activities in boxes, called nodes, and connects the boxes with arrows. The arrows represent the relationship and the dependencies of the work packages. Relationships between activities in a PDM constitute one of 4 different types. Finish to start, FS. This relationship means task A must complete before task B can begin. This is the most common relationship. For example, the foundation must be set before the framing can begin. Finish to finish, or FF. This relationship means task A must complete before task B does. Ideally, two tasks must finish at the same time, but this is not always the case. For example, two teams of electricians may be working together to install new telephone cables throughout a building by Monday morning. Team A is pulling the cable to each office. Team B is connecting the cables to wall jacks and connecting the telephones. Team A must pull the cable to the office so Team B can complete their activity. The activities need to be complete at nearly the same time by Monday morning, so the new phones are functional. Start to start, or SS. This relationship means task A must start before task B can start. This relationship allows both activities to happen in tandem. For example, a crew of painters is painting a house. Task A is to scrape the flecking paint off the house, and task B is to prime the house. The workers scraping the house must start before the other workers can begin priming the house. All of the scraping doesn't have to be completed before the priming can start, just some of it. The main output from the sequence activities process is the project schedule network diagram. But to be clear, this is not the actual schedule, as there are no start or finish dates assigned to each activity at this point. For this reason, PMBOK has another process called develop schedule, which we shall discuss later in this chapter. There are 6 inputs to the sequence activities process. With schedule management, the plan activity list is the main input to sequence activities. It consists of all known activities to be included within the plan, whereas activity attribute includes activity aspects such as detailed description, constraints, assumptions, resource requirements, etc. Having a complete understanding of the project scope will give clues as to the most appropriate order in which certain activities must be carried out. In addition, by using the project scope statement as an aid to the logical sequence, this will ensure that all of the activities are considered and included. One more input is milestone lists. As we already know, milestones are zero-duration activities and will often be created as a result of key activities being completed at a particular point in time. They are also used to name and identify key control points when monitoring and controlling during project execution. Such milestones may influence or impose the sequence of activities and are hence vital to be used here. The tolls we are already familiar with. The PDM dependency determination applying leads and lags. PMP is the preferred technique of displaying logical relationships within the sequence activities process and PMBOK. In this technique, some activity relationships are logically mandatory, while others may be logically discretionary. What could be an example of logical mandatory relationship? The water must first boil before the coffee can be made, whereas a discretionary relationship example would be that the user guide and quick start guide documents are both required, but the sequence of creation is not important. But I choose to create the user guide first because it is a larger document. Hopefully you understand the concepts clearly. Decomposition is a technique used for subdividing the project deliverables into smaller, manageable tasks called work packages. The WBS is a hierarchical structure with work packages at the lowest level of each branch. Based on their complexity, different deliverables can have different levels of decomposition. Beware of excessive decomposition. It can lead to non-productive management efforts, inefficient use of resources, performing work. WBS is created for the purpose of better estimating of time and cost for the project. Estimate of time and cost at the work package level, and then it is rolled up for the entire project to get the overall project time frame and cost. Developing WBS also helps in the management and controlling of the project, as it is easier to track down the activity at the work packages level. How far do you decompose? The idea is to break down the project to smaller components that are easy to track. The lowest level is the work package. Let's discuss the inputs, tools, and techniques and outputs necessary for this process. A lot of the inputs come from the define activities process, but some come from processes from other knowledge area management processes, such as cost, procurement, human resources, and even risk management. Activity list includes all scheduled activities on the project that will need resources, and activity attributes provides data to be used in estimating the resources required for each activity. Resource calendars identify the working days and shifts when resources are available. Resource calendars are developed from input from human resources and procurements management that we will discuss in their respective chapters. Risk events may impact resource availability, so risk register is a valuable input. Cost of resources may also impact resource selection. Project team uses different tools to get activity resource requirements and resource breakdown structure. They use many schedule activities, have different alternative methods of accomplishment in terms of resources. Published estimating data is the unit cost of resources and production rates for an industry that may be obtained from professional organizations. Bottom-up estimating is also used by teams to aggregate the cost or duration of the project by aggregating the cost or duration of the individual work packages. We will learn more of this in cost management.